Everybody. So today we're going to talk about what the Born-Haber cycle is really quickly, and then how to solve the problem that we see in front of us, which is sodium metal plus 1/2 mole of chlorine gas yields sodium chloride solid. So what the Born-Haber cycle is, it's just this methodology that we use to try to make sense of the enthalpy of reaction for a lattice compound, specifically an ionic compound. So an ionic compound, I just want to remind you, is a metal and a non-metal, one or more, but a metal is present. So where students usually get tripped up on this one is that they visualize this. So you can visualize this. Visualize a solid metal, which is sodium, and that it's reacting with a gas, chlorine gas. And then what you get this salt, which we call table salt, solid sodium chloride. And so if you're thinking about that reaction of a solid plus a gas yields a solid, then you might think that the reaction has to do with the gas becoming a solid, right? So solid plus gas yields solid. It makes sense to think that the gas will become a solid. But in actuality, that's not the case. So what the Born-Haber cycle is, it says that what's actually happening is that your solid, your sodium metal, is actually becoming gaseous. And when you have two gaseous materials in contact with each other, gaseous sodium, gaseous chlorine, then those are going to come together and react. And when they come and react, then they're going to form your sodium salt metal. Sodium chloride salt at the end. So it's kind of interesting to understand why a solid becomes a gas when it's easier to think that a gas becomes a solid, but in actuality, it's all about the reaction energy that's going on, and reactions are more favorable when they're in the gaseous state. So step 1, 2, and 3 is how we usually do Born-Haber cycle problems. So you could be asked this problem in a number of ways. They could ask you for a diagram, which I'm going to draw a diagram for you as well. They could just ask you straight up, what is the reactions enthalpy total? They could ask you for just one of the energies or one of the enthalpies that is associated with this reaction. So as I'm going through it, I'll point out what you could be asked, right? So the Born-Haber cycle, again, two things come together. One of them is not a gas, but two things come together and they're more favorable when they're in the gaseous state. So the step 1 is that your reactants are going to, whatever state they're in, become gases. Once they become gases, they become ions. And once they become ions, then it's easy for them to come together to form their ionic lattice. So the problem that we're going to look at is this one right here. Sodium metal plus 1/2 of chlorine gas yields sodium chloride salt. Okay, step 1 in orange, form gaseous atoms. So here we go. I have sodium metal, not a gas. See, it's solid right here. So how do you take a solid sodium and turn it to a gaseous sodium? You have to sublime it, right? So in our states of matter, and we have these transitions, when you go from solid to gas, that's called sublimation. So the sublimation of sodium from solid to gas is 107.5 kilojoules, the enthalpy of that. And so this says D because I couldn't put a delta symbol, but often the delta symbol is represented with a lowercase d. So if I'm forming gaseous atoms, solid sodium to gas, I need to know the enthalpy of sublimation. And so when you're given problems by your instructor, sometimes they'll give it to you in that form. They'll say the energy or the enthalpy of sublimation is blank. So we went from solid to gas with sodium. Now what we're trying to do is the same thing for chlorine. This is where students get tripped up because this happens a lot. So the gas is almost always in a diatomic form, Cl2, O2, F2, some type of diatom, because those are usually gases. So the students will say, oh, well, if I'm already gas, then I don't need to do anything. But I want to remind you that these Born-Haber cycle problems are talking about individual atoms and then individual ions that are coming together. So yes, you are already in gas form, but you're not in chlorine by itself, one chlorine. What you're in is you're in Cl2, not just Cl. So if we want to, draw that really quickly, remember that Cl2 is like this, it's bonded chlorine. So what we need to do is just take it to one individual chlorine atom. And the way we do that is we use what's called the bond dissociation enthalpy, the bond dissociation energy. So basically, how much energy is it going to take me to break two chlorines bond together to just one chlorine by itself? So the enthalpy of bond dissociation of half a mole of chlorine to 1 mole of chlorine is 121.3 kilojoules. Again, your instructor has to give you this information, or they have to give you a chart. Sometimes they'll give you a chart, sometimes they'll give you information. But when you're trying to go from a diatomic molecule, a diatomic gas, to a single atom, you need the bond dissociation energy. Maybe you can just get that from a chart. It's usually easy. Okay, so we formed our gaseous atoms. Now I have sodium gas and I have chlorine gas, but it's chlorine by itself, not the diatomic chlorine. Let's go back to our steps. Now, step 2 was form gaseous ions. Okay, here I have my atoms, but now I need to go to my ions right here. So I'm just going to grab this real quick so I can bring it closer. Oh no. Now I'm going to bring it closer. Okay, so I formed my atoms. Here they are, sodium and chlorine, both in the gas state. And now I need to form my ions. Okay, sodium, we know that always takes an oxidation state of +1. Now, what does that mean? When an atom goes +1, -1, what does it mean when it forms a cation? What it means when it forms a cation is that it lost an electron. So until recently, you learned something called ionization energy. And what ionization energy is, how much energy does it require to remove an electron? Well, we know that's what sodium does, right? Sodium goes from sodium to sodium +1. So when we remove that electron, that's called the first ionization energy. And that's what you're going to need as well. And so again, your instructor could either give you a chart of ionization energies, or they could just give you the first ionization energy for sodium. So for sodium gas to go to sodium cation, its enthalpy is 496 kilojoules. Now let's look at chlorine. We have that one single chlorine, and that single chlorine now becomes chlorine anion. Again, what does that mean? When you have an anion, a negative charge, that means that you were given a negative electron. And we have a word for that. The word for when an atom is given an electron, one, it's called the electron affinity. So the electron affinity here for chlorine is -349 kilojoules. Okay, so step 1, I turn them to gaseous atoms. Step 2, I turn them to ions. Now the last, and honestly the easiest thing you do from here, is you form your ionic lattice. So our ionic lattice was sodium cation. Remember, they work better when they're gaseous ions. Sodium cation plus chlorine anion yields sodium chloride, and that's the lattice energy to form that final step is -787 kilojoules. So here's a question your professor can ask you. They can say, what is the reaction enthalpy of this reaction? Okay, you know how simple it is? Add all those numbers up. So I put the numbers in orange of where we formed our gaseous atoms, and then in pink here where we formed our ions, and then in blue, this was our lattice energy. So the total enthalpy of this reaction is -411 kilojoules. One other question that your professor could ask you, they could actually give you -411 and ask you for the lattice energy, which all you'd have to do is subtract all of these numbers here, the orange and pink, from your final. They could ask you just for the diagram itself, which is what I did here, to show you, what's happening, your sublimation, your ionization energy, and things like that. I hope this helped. Please like and subscribe. Thank you.